Hi guys, this is gonna be a video on 5.3, which I promise will be pretty short. I am skipping through some questions. Where's this? Can't see my tab. Sorry guys. Wait 1 sec. That's weird. I am skipping through a bit of questions, but this is quite similar to 5.2. The real connection or similarity is that whereas in 5.2, we were adding things together. In this, we're going to think of multiplying probabilities, okay? Under the condition that they are independent of each other, okay? So that's why it's called independence and multiplication. In other words, when we have independent events, we want to find the probabilities of those two things happening concurrently, we multiply them. Uh, okay. Skip those. I'll kind of skip these because these are conceptual. You'll be able to do it. This is where we start. Okay. Right. What we're given here, this might be a really fast video, which should be awesome. We're given that they're independent. So when we're asked for P of E and, not or would mean add, and means multiply. So we just multiply these two probabilities. That's it. So let's ask. Okay. There's going to be a couple where maybe they're not independent, but that's the gist. I think having a short video for this will help a lot. I'm not going to put a ton of this on the test. It's an important idea, and it might be one of those things you actually use in real life, but it's okay. Okay, so we have probability tossing tails. So think about it. What is the probability? What is the probability of tails on any flip? 50%, 0.5. So this is annoying, but probability of getting 7 tails in a row is 0.5 times zero point 0.5 times zero point 0.5, right? We have to write that out seven times, so it's going to be 0.5 to the 7th, okay? So whatever that gives you is the answer. Okay? So it's kind of a simple idea. So for a lot of these, I'm only going to show you the first part. I'm going to assume that's enough to get the rest. If it's not, just set up a time where we can zoom and go over them. So we have the SARS COVID test. I'm sure you remember this. Hopefully you don't have to take these. Not fun. Right, sticking that thing up your nose. Remember doing that. We have the probability of getting positive. Let's detect the presence. The sensitivity. So it means the likelihood of it correctly detecting SARS is this number, which is 79.94%. So if we were to take what the question is asking, if you took 5 tests or 5 people, what's the probability if they're positive? It would be this to the 5th power, right? So we it's like multiplying it 5 times by itself. And then for the second part, you're just using this probability, 0.2006 to the 5th, okay? So you're going to see there's a lot of these are kind of the same question, just different topics. So probability that a randomly selected 40, oh, that's a little scary, right? That a 40-year-old would live to be 41. You don't hear that every day. Would be 0.996. So what's the probability that two would survive? So it's this times itself. It gets scary because if you took 100 people, so it means someone might die. A little sad, kind of a sad problem. And these problems get a little dark. But for all of them, you're just thinking the probability raised that power. For part C, that's the complement from the last section. So you have to use this number, but you have to do 1 minus it. Okay, and that gives you the probability that the person doesn't live or dies, sadly. Whatever that gives you is the answer. Okay. Um, so why don't we just do this so that you guys can see. What's the probability? What was it? 0.996739. It's just a little annoying to write these out. Let's do it. 0.99 996,739 squared. It's 6 decimal places. This is ridiculous. 0.99348. Let's see if that's right. All right. And then I have to do the same thing, but this time to the ninth power. Okay, because it's asking 9 tenths or 9 people. Okay, so that's a little smaller point. 9710. That's 453. Okay, so that's 6 decimal places. Let's see if that's right. It is. Part C is a little tricky. So what's the probability that at least one of 9 randomly selected 40-year-olds will not live to be 41? Okay. Well, the way you could look at it is this, and I'll just leave it for you guys. If this is the probability that all 9 live, what's the probability that one doesn't? It'd be one, well, one minus that. Is that right? No. So probability at least one doesn't. From at least one, at least. Yeah. So it should be one minus this point, the one we just got. Okay. That's the answer. And luckily that's a low number, right? It's saying it's about 3% that one person dies. Right. All right. Um, yeah, so sort of the same thing. That's what I said. These are repeat problems. So it's kind of like the same thing over and over. So what's the probability that randomly selected 30-year-old? You guys should try to do these as fast as I read them. Probably randomly selected 30-year-old earns more than their parents. In 1970, only 91%. So that's it right there, right? That's the answer. It's this just converted to a decimal, so it'd be 0.917. Okay. And the rest I'll let you guys do because they're not that bad. Just keep an eye out for complements, meaning if it says not, you have to do one minus the probability. Okay. Um, suppose randomly selected has a probability of 0.2, has a probability of default. So then if it's 0.2 that they will default, then it's 0.8 that they won't. Okay. So that's just complementarity from the last section. This is one of those problems I apologize for. Just do your best on these. I know they're annoying, right? You have to like get all of these perfect, but like I said, I wanted to keep these a little bit shorter because the chapter 6 stuff's can be tedious. And yeah, players are said to have hot streaks and cold streaks. So what's the probability of a person getting on base? Probability. Well, if the probability that the person fails to get on base is 73%, then the probability that they get on is 27%. So you would do, okay, this is the probability that they get on base, and then you convert that to a decimal, and then to do it 10 consecutive times, it's that raised to the 10th power. Okay. So that's that. I know we're rolling through these. And sort of the same thing here. 29.3% have driven under the influence of alcohol. So it's that probability raised to the fifth, right? So it'd be 0.293 to the fifth. Okay, and then just proceed through them carefully, and you'll get the rest right. Okay, this one was just multiplying two probabilities together, so it's just 0.39. This is a simple one. Times 0.0. That's it. We're almost done with chapter 5, which is great. This is one I definitely have to explain. So it looks complicated, but it's not bad. So you open this. So it's asking the probability of going from phase 1 to phase 3, and you have to go step by step. So you have to do the first probability of getting from phase 1 to phase 2. Why are you not writing? There we go. Times the probability of going from phase 2 to phase 3, and that's probability of going from phase 1 to phase 3. So for this one, from 2 to submission, that's this one times this one. Okay, so whenever it skips things, you have to multiply the probabilities. Okay, so I think that will help. And we got two more. Um, yeah, I shouldn't guess on these, but I guessed. And this one is asking probability of male and bets. So you just multiply these two probabilities together. And 16 is going to be, let's see, two randomly selected 4-year-old male. So it's just multiplying this times itself. Okay. And then if it's 5, it's this times this times this times this 5 times, or 0.98124 to the fifth. That's it, guys, for 5.3. We have one more section to cover, and I'll record it soon. Thanks.